The first part, I will try to discuss the doubts, and if there is a time, I will revise the topic if you want any. But first, I prefer to answer doubts from different perspectives. Discussion is about the magnetic field around a bar magnet. Figure 7.1 shows the two positions used by a student doing an experiment. Figure 7.2 shows a magnet labeled magnet 1 placed on position 1, as you can see here. And on a figure 7.2, draw the lines to show the pattern of a magnetic field produced by a magnet 1 and place an arrow on the line shows the direction of the field. So the magnetic field is always pointing out from north and into south. The field line should be closer. The first. Okay, this is a question. Maybe my screen was not visible initially. This is a question. Uh, so the first part, figure 7.2 shows a magnet label magnet 1 and it is placed as position 1, as you can see. Then on a figure, we have to draw the pattern of a magnetic field produced by magnet 1. Place arrow on the lines to show the direction. So the direction of a magnetic field is out from north and into south. The near the poles, because it's a stronger magnet, like this near the poles, the magnetic field is stronger. So the field line should be closer. The next part is magnet A is removed from position 1 and figure 7.3 shows another magnet labeled as magnet 2 is position at position 2. Now on a figure, draw at the right hand of position 1, like here we have to field lines to show the direction of a magnetic field produced, because we know and we have to show an arrow as well. So if we have like poles repel each other. So how we represent the magnetic field lines? No, it's like poles. Like as you can see, position 1, we already have this magnet. The magnet, like magnet 1 is removed from position 1. It was initially there and now shows another magnet, which is magnet 2 is on position 2. So on a figure, draw the at the right hand of position 1, a line with an arrow to show the direction of a magnetic field produced by magnet 2. So this position 1, the magnet is being removed. So we have to show the direction of a field line. So it is out from north and into south. It's not like, yeah, so position 1, we don't have any magnet. We don't have anything. Like here we remove according to a question. Magnet 1 is removed from position 1. So we just have to show the same pattern of a magnetic field, which is pointing out from north and into south. But we don't need magnetic field. We just need draw at the right hand of a position 1, a line with an arrow to show the direction of a magnetic field produced. So what is the direction of a magnetic field produced? I'm drawing first a magnetic field to give you an idea that this is out from north and into south. So what will the direction I will draw? The direction I will draw only outward. That's it. Is it clear? Because there is no magnet here. If there was a magnet, like if two magnets were placed and their like poles are facing each other, we have a north and south, and we have a north and north. If like poles are facing, yes, we will draw the magnetic field in this manner. But in the question, the position 1, the magnet is removed. Like from position 1, there is no magnet. So if you don't have a magnet, a pattern of a magnetic field is because of this magnet only. And the direction of a magnetic field is always out from north and into south. The next is another sample of a gas is in a sealed container with a volume 170. So this is V1. Exert a pressure. So this is P1. The volume of the container decreased by 70. So if I decrease the volume by 70, for originally it is 170 and I decrease the volume by 70. So what is the new volume? The new volume will be 100. Because originally it is 170 and it is decreases by 70. So how much the volume of a gas is there? That will be equals to 100 cm cube. So we'll have 100 cm cube. So what is the mistake here? That instead of V2 to be 70, because it's not like its volume decreased by 70. It's not like volume is 70, it's volume decreased by 70. So that's why the total volume will be 100. And it's a constant temperature. So we use a Boyle's law, P1 V1 equals P2 V2. So the mistake here in this question is the volume decreased by 70 means the total volume was 170. If it decreased by 70, it means the remaining volume will be 100 cm cube. Is it clear, this one? When we have a distance time graph, what we use, if a question is about distance time graph, use the term speed to explain the motion of an object. What happened from Q to R? So Q to R, you can see it's a straight line. So if it is a straight line, we can say a constant speed or a uniform speed. What happened from R to S? So from R to S, you can see the slope is decreasing. So if the slope is decreasing, so it means the speed is decreasing or it is decelerating. And from S to T, the object is stationary or at rest. So from R to S, the slope decreases. If a slope decreases, it means the speed decreases. But in the marking sheet, it was decelerating if I write decrease. Yes, it's fine. In the marking scheme, it is like explaining a motion. Decreasing speed also refers to deceleration because deceleration means the decrease in speed. So if you write, because look, the simple rule, remember, if it's a distance time graph, use the term acceleration, use the term speed to explain the motion. If it's a speed time graph, use the term acceleration to explain the motion. So it's fine when you write decreasing speed or decelerating. Kinetic energy of a ball is 4.5 before the collision and 0.2 after the collision. Calculate the change in total kinetic energy of a ball and the object. Send me either a full question of this or the exam paper, like the year. I will open the PDF and solve because it need first part as well. No. That is not 4.5 minus 0.2. It's of 3 marks. The previous, it's of 3 marks. So you cannot just subtract and get the answer. Calculate the total change in kinetic energy. That's why I need a question, full question to see the question and then I will answer according. It's 3 marks. They definitely, it's not like you just subtract 4.5 minus 0.2 and you get the answer. So they do give you mark, but not that free that. Okay, this question already one of the student have sent, so I will discuss from that. My neighbor आ गया. रुक इसे ये मैंने भी किया है कौन सा पास पेपर है सर यार मेरी भी इसमें वो doubt. Figure 3.1 shows a boy throwing a ball at an object in a fairground. As you can see, a boy is throwing this. Show me the hard copy. Yes. The ball has a mass of 190. Paper. This is October 3rd variant. Okay. 23. The ball has a mass of 190 grams, travel horizontally with a constant speed of 6.9. 43. No, because question is, she needs the question for the next remaining one. So calculate the momentum of the ball. If you need the momentum is a product of mass and velocity. So when mass of an object multiplied by its velocity, we get the momentum. But the SI unit of the mass is kilogram. So it is 190. So 190 gram is there. What we have to do, we have to divide by 1000 to convert into kg. So that is equals to 0.19 kg. And multiplied by velocity, which is 6.9 meters per second. So when we multiply them, we'll get 1.31 kilograms meters per second. In speed, direction inversely proportional to speed. Is speed directly or inversely proportional to speed? You mean acceleration? Okay, next. The next part, after hitting the object, the ball bounces back in the same straight path. With a speed of 1.5 meters per second, the object has a mass of 1.8. Substitution mistake is there. Calculate the speed of the object after it hits the ball. So if we, as you can see, like the first part of the question, whenever objects colliding, we use a conservation of the momentum. The total momentum before must be equals to total momentum after. So what is the momentum before for the ball? As the ball was moving, it was 1.31. That is the momentum of the ball before it moved. What is the momentum of the object? The momentum of the object is 0 because it is not moving. Then the object has a mass of 1.8, and as you can see, after hitting the object, the ball bounced back along the same straight path. So the ball bounced back. So the ball has changed the direction with a speed of 1.5. So the speed at which the ball is moving, that is 1.5 meters per second. And the mass of the ball is 0.19. We need calculate the speed of object after it hits. So what we'll use a conservation of the momentum. We'll say the momentum before must be equals to momentum after. The sum of the momentum before collision must be equals to sum of the momentum after. So momentum before for the ball is 1.31. Okay. Or you can also substitute the values, like directly you write 1.31 or you show a substitution. Say the mass is equals to 0.19. Okay. Multiplied by velocity. What velocity the ball was moving? Initially, the ball was moving at a velocity of 6.9. So 0.19 multiplied by 6.9 plus the object was stationary, so the momentum of object is 0 equals to the mass of the ball is 0.19, but the ball bounced back. So what I should substitute, this velocity of 1.5 when the ball bounced back, I should not substitute as positive, I should substitute as negative. Okay. And what we assume when the ball hits the object is moving towards right and the ball is bounced back. Okay. So the velocity of the object is x. We don't know its velocity. So it will be 0.19 multiplied by what? Multiplied by negative 1.5. Why negative 1.5? Because ball was initially moving with a speed of 6.9 and then it bounced back with a speed of 1.5. So if the right hand side is a positive velocity, left hand side will be a negative velocity. So that is the momentum of the ball. Plus, what is the momentum of the object? The mass of the object is 1.8. And what is the speed of the object? The speed of the object is x. Now we'll solve 0.19 into 6.9. That was 1.34. 0.19 into 6.9, Aram or Abdullah. 0.19 into 6.9. 1.31. 1.31, okay. Plus 0. And what about this one? 0.19 into 1.5. Yeah, how much? 0.8? 0.285. And plus 1.8x. Now we simplify, 0.285 will move other side. So 1.31 plus 0.285. is equals to 1.8x. When you sum
1.595.
1.595,
The answer will be 0.88.
595 divided by 1.8. What's the answer?
0.88.
So when you simplify 0.88 meters per second, that will be the final answer. Yeah, 0.88 is the final answer when you simplify. So what we did, we use a conservation of the momentum, that the total momentum before is equals to total momentum after. So the momentum of the ball before, this is the momentum of the ball before. The ball was having a mass of 0.19 and moving at a speed of 6.9. The momentum of the object is zero. The object is not moving. The momentum after, because of the ball bounced back, so the mass is 0.19, but the velocity is not 1.5, the velocity will be minus 1.5 because the direction has changed, opposite. So how we show the vectors in opposite direction, we take an opposite sign. If it is like right hand side, all velocities are positive, left hand side will be negative. And then we have 1.8 into x. Why? Because we assume the object will move. Let's say this is our assumption that the object, and to conserve the momentum, if one object is moving towards right, the other should be moved towards left. The resulted momentum will be towards the right hand side. Is it clear, this one? Yeah, total momentum before is equals to total momentum after. The total momentum before is towards the right hand side. So total momentum after should also be towards the right hand side. So if one object is moving towards left, the other object should move towards right with a higher momentum. So the total of these two will be towards right hand side. So all this is it clear, this one? Should I repeat? Repeat. 6.9, 0.69 you mean?
Oh.
This was the velocity was given. Look, in this question, a ball is moving. Look, let's say the initial momentum is 10. So when it collide with anything and bounce back, so if this has momentum 2, the other object should have a momentum of 12. So the result of these two will be equals to 10. That is the conservation of the momentum. That the total momentum before must be equals to total momentum after. So this, we have an object which is having a mass of 1.9 gram or 0.19 kg. And it is moving at a speed of 6.9 meters per second. It collides with an object which is stationary. If anything is stationary, its momentum and its velocity or speed is zero. So what is the total momentum before? The total momentum before is 0.19 times 6.9 plus 0. So when we sum this, we got 1.31. That's the total momentum before. For total momentum after, what they said that the ball bounced back after hitting the object. So an object is moved, we assume object moved towards the right hand side. So as the ball bounced back, the velocity of the ball is 1.5 meters per second. The mass of the ball is again 0.19 kg. The mass of this object is 1.8 kg. We need what speed the object will move. Yeah. So now what we'll do, because initially when the ball was moving towards right, the velocity was positive. So means that if the ball rebound, what should be the velocity? The velocity should be negative, or the momentum should be negative because it is in opposite direction. So what is the momentum after collision? So mass into velocity 0.19 times negative 1.5 plus the mass is 1.8 times x. So when we simplify this, 0.19 into 1.5, it was, what was the answer for this? 0.19 times 1.5. 2 point? 0.28, okay. So this was 0.28 and this is 1.8x. So this is a momentum after and this is a momentum before. So we will just compare conservation of momentum whenever object collide or explode. So this will be equals to 1.8, 1.31. That is a momentum before is equals to momentum after minus 0.28 plus 1.8x. This will move other side because it is negative, other side will be positive. So 1.31 plus 0.28 and then 1.8 is multiplied, other side will be divided. So when you simplify this, the value of the x will come out as 0.88 meters per second. So this is how we use the conservation of momentum when objects are colliding with each other. Is it clear now?
Last one. Last one. Last one. 4 days.
Look, one of the student asked like how we can say that if the object move on one side with a higher momentum or we have a resultant momentum, then how can law says momentum before equals to momentum after? Look, how the law says that the momentum before is equals to momentum after. If you have an object, it has a momentum of let's say 10 and it is colliding with an object. So what is the total momentum? 10. When the object collide, let's say it's bounce back. So if the object collide and bounce back, if it this collided and bounce back with a momentum of 3, or because it is bounce back, so it will have an opposite momentum. So if this is 3, what should be this one? This should be 13. Why 13? Because minus 3 plus 13. So minus 3 plus 13, what is the result? The result will be equals to 10. So that's how like even one object has a 10 momentum initially and the other object 0. So the total is 10. When they collide, if one bounce back, that has an opposite momentum like minus 3. So the other should have a plus 13. So the result should be 10. So total momentum before should be equals to total momentum after. The next part is calculate the change in the kinetic energy. Which one? No, here. Calculate the change in kinetic energy. The kinetic energy of a ball before the collision is 4.5. So the ball was moving. What was the energy of the ball? The energy of the ball is 4.5 before it collides. And it is 0.2 after the collision. So once it collides, it has a energy 0.2. Energy is a scalar quantity. It does not depend on the direction. Like if a direction changes or not changes. No. If direction changes or direction does not change, it does not depend. Okay. Then if you see it collided with the object, initially the object was stationary, so it does not have any kinetic energy. Then the object move. At what speed the object move, we calculated the speed at which the object move is 0.88 meters per second. And what was the mass of this object? The mass of this object is 1.8 kilogram. It's given in the question that the object bounce, like we calculated the speed at which the object move, that is 0.88, and the mass of the object is how much? The mass of the object is 1.8. So what is the kinetic energy? Use a formula for kinetic energy. Kinetic energy is half mv square. So it will be half. The mass is equals to 1.8 and the speed is 0.88 square. What's the answer for this? 0.88 square times 1.8 divided by 2. What is the energy of the
8.65. So that's 1.8. 1.8 multiplied to 0.8.
1.8 times 0.88 square. 0.88 square
0.6
and divided by 2, the final answer. 0.88 square
0.34. The answer. What about that?
times 1.8 divided by 2. 0.69?
0.69. And divided by 2 is 0.34.
No. This whole answer I got because it was 0.88 square,
But divided by 2.
half mb square kinetic energy. Multiplied by mass, which was 1.8,
Yeah.
and then that is divided by 2. So 0.69. This is 0.69 joules. So
So can we round it off? Like
0.7?
Can we round it off for?
No, 0.69 or 0.7, that's fine. You round.
Yes, it.
Look, it is half mv square. Half multiplied by 1.8 multiplied by 0.88 square. First do 0.88 square.
Yeah.
0.88 square is 0.7744 times 1.8 and then it's divided by 2. So 0.69.
Divide by 2 to the left side.
First 0.88 square times 1.8. The final answer, do it this and then the final answer divided by 2.
What's like this first?
No, not this. First do it this multiplication part, remove this. First 0.88 square. First you solve a numerator and then just divide it by 2, you will get the answer. Yeah, 0.5. That's what I'm saying. Look, what we are doing, this is, look, 0.88 square multiplied by 1.8
And we add
got equals to
1.3
divided by 2. Yeah. Look, in the question, the kinetic energy of the ball is 4.5 before the collision and after the collision is 0.2. The question is calculate the change in the total kinetic energy of the ball and the object during the collision. So when they collide, what is the total change in their kinetic energies? That is what we want. The total change. So what we will do, what is the change in kinetic energy for the ball? First, it was having a kinetic energy. For kinetic energy, we don't need a direction. First, it has a kinetic energy of 4.5 joules. Okay. Then it has a kinetic energy of 0.2 joules. So what is the change in kinetic energy of the ball? What is the change? For energy, because it's a scalar, so we don't bother about its direction. So this is 4.5 and this is 0.2. So when we subtract, we got 4.3 joule. That is the change in kinetic energy of the ball. Then what is the change in kinetic energy for the object? Initially, the object was stationary. The object was not moving. But then when the object collide with the ball, the object move at a speed of 0.88 meters per second and the mass of the object is 1.8. So what is the energy or the kinetic energy of this? What is the energy or kinetic energy? So kinetic energy is calculated by a formula half mv square. No. Half mv square, so it will be half multiplied by m, which is 1.8 multiplied by 0.88 square. This will give us the kinetic energy of the ball, which is 0.69. 0.69 joules. So here it is 0, here it is 0.69. So how much is the change in energy of the object? So originally it was 0 and now it is 6.9. So change in energy of the object is 0.69. Because originally, now the question is the total change in the energy. What is the total change in energy between the ball and the object? So the change in energy of the ball was 4.3 and the change in energy of the object is 0.69. So what is the total change?
plus number.
Subtract, change.
Why?
Change.
Change when you guys said. Exchange के बाद में 5,000 की शॉप कर देगा
Change means difference. So what we did, yeah, look, we got the question is calculate the change in total kinetic energy of the ball and the object. So what we did, we calculate change in energy of the ball, we calculated the change in energy of the object, and then we take a difference of their changes. Because that is the question, that change in the total energy, total kinetic energy of the ball and the, that is the change in the energy of the ball. And then the kinetic energy of the ball object, yeah, half mv square, that was 0.69. No, not 0. This is not 4.5 joule is the energy of the ball before, zero point 0.2 is the energy after. So what is the change in energy of the ball? That was 4.3 joules. What is the change in energy for the object? The object was originally at rest and we use a formula half mv square from the previous part. We calculated the using this formula half mv square. So it will be half into 1.8 into the speed square. It was moving at a speed of 0.88. So we got this answer as 0.69. So what is the change in energy for the ball? That is 0.69 joules. And what is the change in energy for the object? Sorry, this is for object. What is the change in energy of the ball? 4.3. We need the change in this, the difference. The object was initially at rest, so it does not have any kinetic energy. Then the object move with the speed. They mentioned the object move at a speed of 0. Like we calculated in the previous part, it move at a speed of 0.88 and it is having a mass of 1.8 kilogram. So what is the energy? Kinetic energy using a formula half mv square. And speed from the previous part. Yes, speed from the previous part. The speed is not given in the previous part. We calculated that. Momentum before equals to momentum after. Oh. So you simply what you have to do, energy before for a ball, energy after for the ball, the change in energy of the ball 4.3. Energy for the object 0, energy after that is 0.69. The change in energy is 0.69. And the question is calculate the change in total kinetic energy of the ball and object during a collision. So what is the total? 4.3 minus 0.69. That no, energy is a scalar quantity, so negative does not make sense. Yeah, energy can never be like, because scalar quantities, if I say time is minus 2 seconds, what does it mean? Means you are, yes, so energy cannot be scalar. Less than a minute left, so use the same link to join again.